All right. Good afternoon. Good afternoon, Internet. How's it going, eh? All right. We're here. We're here for stream 24. That's right. We're here for stream 24. Math tutoring. And yeah, I'm dressed up in my Canadian costume here, just to I got some nice red plaid, got a camouflage chapeau. I'm surprised that it comes up on my chroma key, right? You'd expect like my head from here up to just be invisible, right? But you know, who am I to say how transparency is supposed to work? But you would imagine right now that you wouldn't be able to see this hat, right? Either way, this is this is my 24th math stream. We call it a 2-4 because a 2-4 is a case of beer. Isn't that right? Yes. And it is a bit topical. It's not just a pun on the number of days that I've been live doing this for. But we did find out now just yesterday about some um, about how the COVID-19 restrictions are being lifted, or not lifted per se, but relaxed a little bit if we're able to carry on and keep the numbers nice and low, which means we might be ready for the most important weekend of this. Well, maybe not of the year, but of the spring for sure, which is May 2-4, right? You break out a 2-4 on May 2-4. So, in honor of my 24th stream and the possibility that we'll be able to go to the cabin again on May 2-4, I'm going to crack open part of a 2-4 here right now on stream. Oh, here we go. Listen to that. Yeah, it's good stuff. It's good stuff. Get that click. That's right. No coffee on stream today. We having lunch beers. That's right. Or one beer. Right. And like I said before, like if it's 5% or under, that's basically just water. So that's why I'm on the Molson Canadian today, right? Also for the stereotype, right? You know, plaid shirt, camo hat, and a Molson Canadian. Boy, oh boy. Mm. And just pulled them right out of the earth, didn't we? Yes. Oh, it's impossible. It's impossible to be more Canadian than that. Well, while I'm here rambling, before we get started here today, let's take a quick look at what they're saying for the Newfoundland COVID-19 sort of alert level. You flick on over here. This is off NTV, right? Canada's superstation, as we're told, right? Canada's superstation. I there's a good rant in this actually. There's a really good bit about like those late night commercials that you'd see on NTV, like Jeff Sterling just came to him in a fever dream sometime, and you get like these super cuts of like hallucinatory colors with like Captain Canada flying through it. It's bizarre. Man, remember back in the day when like TV, there was a time when TV wasn't going, right? There would be off hours for TV. I'm gonna take this hat off. There would be off hours for TV, and like after the stations ended or whatever, NTV and some other stations would just keep going. Like a Vegeta thing going on here today. Look at this. Look at this. This is pretty good. Try over 9,000 times to get my hair to come out like that. Um, yeah, there was this time when like stations would stop for the day, and then it would just keep playing afterwards with like this just complete hallucinatory nonsense. It's incredible. And like late night NTV from the 90s should really be enshrined in some sort of TV museum someplace. Anyway, so here we see, what if we carry on until May 11th, as we see here, with our good numbers, maybe we'll have the alert level restricted a little bit, right? Because currently it's at alert level 5, like we see here. May the 11th, might be able to ratchet that one back, ratchet it down a little bit, right? Low risk, this is what I'm looking at. See this part here? Low risk outdoor recreational activities can resume, right? They show a person golfing here, so I imagine golf's going to be part of it. But that should include going to the cabin, right? As long as there's not too many people there for a party, we'll be able to do it. Because, of course, right, Victoria Day. Victoria Day is coming up. Victoria Day holiday in 1 week from this, actually, May 11th. 1 week after that is May 18th. That is Victoria Day holiday, or May 2-4, as we calls it, right? But it's not May 2-4 because it's May 18th. But that's beside the point. It's not really important. The important part is that you got to go to the cabin, That's right. Got to go crack open a warm one. Drain one of those cans of Vienna sausages that you've been hoarding, right? Well, I know you're out there doing it, right? Of course. Like when some people go, they start hoarding things like flour or, I don't know, sugar or milk. But, we got to go get some hoarding some Vienna sausages, right? Super important to have those. Oh, crap. NTV. No, what are you doing? No, get rid of this. Ah, NTV's website. Okay, here we are. We're back. We're back. Alert level 3. No, we're not to that yet. Here we go. Yep. So, hopefully, this comes to pass. We can get some low risk outdoor recreational activities and we can get out the cabin for May 2-4. That'd be great. Great, wouldn't it, buds? That's right. Connection with one under other bubble, actually, on April 30th. Well, that's great for me. That's great for me because that means I can go back up and start talking to the cashier at the liquor store again. That'll be my second bubble. My second bubble, it'll be me and then the person who supplies me with this. Delicious. Super important, right? Got to get out. Once upon a time, I would have said like, I don't know, a dealer or something, right? But we can get green whenever you want now. We're in Canada, right? You can get that like shipped to you in the mail. Who even cares? Who even cares? Anyway, I'm kind of a lightweight for that. Anyway, I do like a boy if I. Anyway, gonna move on. Gonna move on before I incriminate myself too much. Although it's not criminal anymore, but I don't know that work is gonna smile on it too much if I'm just here talking about booze and weed. Anyway, flip on back over here. We see we got another picture, got another good one. This is one of me. Clearly, it's an action shot, right? I'm splitting some wood up at the cabin, right? Because it's in the winter. Hopefully, I can get back to that now. Maybe in a week's time. Maybe I'll have to drive all the way, all the way across the province over to almost Deer Lake to spend 2 days cleaving wood. But hey, these are you got to do what you got to do, right? You know, it's my choice to live in Newfoundland. I knew I knew what the distant situation in the province was like, right? And if it's a bit warmer, maybe it'll look like this. Hey, look at that. Now that's good. This matches my plaid shirt for today, doesn't it? Yeah, this is good. It's me out cleaving up some wood again with the old. We see it right here. Oh yes, yes, there it is. Yeah. It's the most important machine ever hit the island of Newfoundland, right? You think it's like the outboard motor or something like that? No. No, the most important machine for this island is the Honda Big Red right there. Oh yes, oh yes, my son. You ever go anywhere in the interior of the province, you get one of those guys. I think that machine is from 1988. Still runs a dream. It's crazy. I don't know. They don't build machines like that anymore, right? Honda Big Red. That's an icon. That's what that is. Anyway, here rambling and wearing a costume and all this. Boy, you'd think that I don't want to do any math, right? We're almost 10 minutes in. 8 minutes of live, 2 minutes of sitting here waiting. And I haven't even mentioned math yet. So, without further ado, let's get on to some of that, right? Let's go over. So we're going to do scatter plots and linear relations today. It's going to be the first thing that I get onto. Then after that, I'm going to do direct and partial variation, which is basically the same topic, just a bit further on. Then I'm going to do some on systems of equations and word problems, because I actually noticed that I don't have an answer key for an activity on those. So I'm just going to go through and make that however long it takes. Y'all can just watch me blather, right? Anyway, flipping on back then, so let's go over to my document display. Here we are. This looks appropriate, doesn't it? This is an appropriate getup for the scene that I have behind me here, isn't it? It's great. Some nice primary colors. It looks good. Right? We get the blues and the greens and the reds. And then the oat sodas. Another oat soda, Gary. Anyway. I think that was my first Big Lebowski reference on stream, wasn't it? I haven't actually made one of those before. Look at that. Weird. I can't believe I could have gone as long as like 24 streams without mentioning the greatest film ever created. All right. So this is Math 3102A Unit 3. So Esther, if you happen to be around and be watching this or if you're watching it in the future. I hope this helps you because these are some of the first questions out of the notes that you're going to have to do. Page 117, question 1. And we'll start off with A, like you do, right? So state whether each scatter plot shows a linear trend between the variables. If so, is the trend positive or negative? All right, so all a linear trend means is, does it roughly make a line, right? That's it. That's all. So over here, we're going to look at these first points. Oh, my cursor's not coming through. There we go. Excuse me. Boy, I should not have had like a quarter of a beer on stream. Now I'm going to be gassy. This is not it's not good broadcasting, right? It's really not. You don't want to hear someone burping on radio. So across here, but it's Twitch streams, right? Twitch streams are sort of delightfully raw and not really edited or proofread or anything. It's just a live feed straight from the bowels of my house. Yeesh. So state whether each scatter plot shows a linear trend between the variables. If so, is the trend positive or negative? So a positive trend basically means it's going to go up. So a positive trend, I'll write this over here actually as an aside because we're going to need to have that over there. Sorry for reaching across and making my lighting go all wonky. So a positive trend means it goes up as it goes right. That's a fairly straightforward one, isn't it? Positive trend goes up as it goes right. So if we had like this, say those were the dots, we would make a better line of best fit like there, like that. So this is a positive trend. Okay? So the negative trend then, guess what? Negative trend is gonna go down, right? It's not hard. And we're always looking at as it's going to the right. We're not concerned about how it goes to the left, right? Even if occasionally, sometimes it might look intuitive to go left because you'll be starting up here, say, and you think about going down. But a negative trend is we always read trend from left to right. Right? Like say that was roughly the points. Well, that fairly clearly, the line of best fit is going to go down like so. So that then is a negative trend. This is the Y and this is the X. I'll fill in the other stuff that I left out over here as well. That's the Y and that's the X. Okay? So that's basically all we need to know for these guys. And once we're armed with that piece of knowledge, we can just go ahead and solve all these. So state whether each scatter plot shows a linear trend between the variables. So this one is definitely linear. And we know it's linear because they're roughly in a straight line. That's all that means, right? Later on, we will see that there are other types of relations as well. It's not only linear positive, linear negative, linear zero, and no relation or whatever, right? You can also have curves like a quadratic or a cubic or a quartic. We'll see stuff like that later. But for now, we're just going to be talking about straight lines only, no curves. So A is linear and it's positive. It's positive because it goes up as it goes to the right, right? Like we show over here, going to the right, going up. That's all. B, well, B just has points scattered all over the place, right? So if points are scattered all over the place, that's going to be no relation. No relation. C is going to be linear and negative, meaning it's going down as you're going to the right. Right? And then D, how about D? D is a little bit, not really trickier. Um, I guess a little trickier. Because if we see A here, A is very, very clearly linear. D, D is a little bit off, like it looks like it curves a bit like that. But if we were drawing a line between these ones, we would definitely say that this is linear and positive, for sure, right? And remember, when you're doing a line of best fit, like if I had to do a line of best fit for this, I would not do straight to this point, straight to that point, straight to that point, straight to that point, and have it be like an S, like an elongated S shape. A line of best fit goes straight through the points, right? Now, let's see. Question 2, I think I can carry on and do that one. Create a scatter plot of each set of data and state whether the scatter plot shows a linear trend between the variables. If so, is the trend positive or negative? Okay, so I'm going to go ahead and draw out a coordinate plane, or not a full plane. I'm going to draw quadrant 1. But remember, Esther, because you're the one who's doing this course right now, remember that, like I keep saying every single freaking time I do these questions, don't draw it like I do. Don't do what the teacher does, right? Teacher is doing this because teacher doesn't have any graph paper. But since you hopefully have graph paper, draw these on graph paper. If you don't, well, let me know. Send me an email and we'll talk about what we're going to do for graphing these if you haven't got graph paper. But if you do have graph paper, perfect. Marvelous. Just go right ahead and use that. That's the way to do it. Okay? So I'm just going to start marking off some gradations on here. This is going to take a bit longer than it would, if I had graph paper, like I'm saying. Go across there, do a few ones across here. This pen, see, this is the pen that replaced my good black one that I had when I started. It's yeah, it's a little bit smudgy, which is too bad because I need to be able to like move my hand over the page immediately. Okay, so this is of course our x's down here, and this is of course our y's up here. Now I'm just going to, because we're kind of seeing if these are linear or not, the fact that I'm going to be a little bit off is not, it's not a super big deal, right? Because I'm not going to be perfectly accurate with all these. So 2A, I'm going to do 2A in black. Okay. So 2A, we've got 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 6, and 9. Huh. Okay. Because see, we look at the y's. If we look at the y's over here for set 2, we see that the y's are 1, 2, 3, 4, 5, and 6. So at a glance, we might say, oh, it's obviously linear. 1, 2, 3, 4, 5, 6. How could you get more linear than that? Right? But you've got to pay attention to both of these, right? So let's graph these as coordinates, which is what they are, right? This is x and y, so this is a series of coordinate points. 0, 1, 1, 2, 3, 3, 4, 4, 6, 5, and 9, 6. Okay, so 0, 1 is going to be right here. I'm going to graph that one. Then we've got x1, y is 2, which is going to be right there. Then I've got x3, 1, 2, 3, y3, 1, 2, 3. So that's going to be about there. Then we've got x is 4 and y is 4, so that's going to be here like this. And then I've got x is 6, 6, and then y is 5. 6 and 5 is going to be, I'm going to have to start using this like so to find the point. That's pretty good, actually. That's a good way of doing it. That works. 6 and 5 is, wait, 1, 2, 3, 4, 5, 6. Oh, that was 7. Crap. Crap. We'll get there eventually. So that one's the one. So I'll put an X there on that guy. And then the last one that I need is 9, 6. 1, 2, 3, 4, 5. I'll start marking these off. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 16, 17, 18, 19, 20. All right, that'll help me a little. 15. Okay, that'll make things a little bit easier. And now the last one that I need is x is 9. So the x is here on 9. And the y is 6. So that's over here. So that's going to be on my corner of the triangle here. Now what do we got? Well, here's the points, right? Don't mind this. Don't mind the dot one. That dot one was there by a mistake. This one's a mistake point. So the other ones, these x's are the points. So is this a linear trend? Well, it's roughly linear, I would say. And it's roughly linear and roughly positive. Right? Because it's not directly a line, and we can see it's not a perfect line by any stretch of the imagination, right? But we can see that, say if I drew a line, I don't know, let's say here. Yeah, this looks about right. So that looks to be roughly the line of best fit there. Okay? And if I zoom in a little more, a bit more, you can see over here, some are above, like this, some are below, like this, right? But I have roughly drawn a line of best fit that goes across there like so. And you can do this in technology as well, by the way. A TI-84, like a calculator like that, is a really good way to draw an actual line of best fit, right? You can, by actual, I mean sort of the calculator figures out what's the best average of all those points, right? And you get sort of an R value for those. Now, I'm not going to show you how to do those because for whatever reason, this course doesn't go on to do that. Now, in my mind, as someone who's done a bit of stats, that's kind of the point, right? Is to, because an R value, once you do a line of best fit or a regression, right? We call that a linear regression, which finds a straight line of best fit. You then get an R value afterwards, which tells you basically the accuracy, like how close the line of best fit that you've generated is to the actual data that you're using, right? So here you get a fairly good R value, like a close to 1, but it wouldn't be equal to 1. I don't know, maybe it would be 0.9 or something like that, right? Because an R value of 1 means it's exact. But anyway, that's a topic that you're not going to get into, so don't sweat about the R values, but it's good to know that that exists, right? And it's a way that you can judge how precise your line of best fit is. Let's go do 2B here as well. We'll do 2B in blue. So 2B, boy, x is 0, y is 10. So that's up here. X is 1, y is 10. So that's straight across there. X is 4, and then y is 7. So 4 and 7 is going to be there. I'm using this like a carpenter's square, as you're seeing, right? Because since I know this is a right angle, as long as this side matches up with the y's and this side matches up with the x's, I actually have the correct point here, right? So it's just a way of making do, right? Chibudo, I think. That might be I don't know. Maybe now is not the time. 6 and 4 is the next one. 6 and 4 is right here, this point. And then our last one is, oh no, we've got 2 more. 8 and 3. 8 comma 3, which is here like this. And then 10 comma 1, which is here like so. And now if we look at these blue points, let me zoom in again, right? Because I'm out a bit far here, and I think it's difficult to see on the stream what exactly is happening. But if we look down here now, we see that the blue ones go straight across and then down to here. Then so it goes this, and then it goes sharply down, and then it goes less sharply down. This is not a very good linear relation. But once we graph them all, it is roughly linear. So I'll call that negative. And as long as you tell me that it's roughly linear or like, it's not linear, but it's kind of close, right? Because in terms of like an actual straight line like you would get in a math problem, like for an equation, obviously 2b there's no direct line equation that will represent this data here as a straight line. But in statistics, of course, it's a much more imprecise sort of thing, right? Where you've got to take um, sort of bundles of data and try to see if they have any sort of relation amongst them. Now, of course, in a statistical regression, 6 data points is not very much at all, right? So it's barely enough to make any sort of conclusive analysis. But from just these points that we've got, there does seem to be kind of a linear relation going on, right? Some points are above, some points are below, but it does seem like the linear relation is kind of that, right? And that is drawing the line of best fit. Okay, so I'm going to put line of best fit there for that one. And this one here was a line of best fit as well. FTI, what am I doing? Line of best fit. There we go. Right? Okay, I don't think I particularly need to go do a whole lot more of these. Let's do one that is totally crazily out to lunch. Yeah, so let's do C. All right, so 2C I'm going to do in red, like so. Because I want to show some that are sort of edge case examples. And Esther, these are good examples of the kind of stuff that you're going to be doing throughout this course, right? Yeah, there we go. Some nice carbonated bread. It's good for you. We like to drink till we spew. Ooh, who cares if we get fat? I'll drink to that as we sing once more. I was just thinking about that yesterday, Like, what modern comedians have the enduring appeal that some like older ones might have had? And I think Weird Al. I think Weird Al is going to go down as a guy with some real enduring appeal, right? Like he's been making parodies since what, like the early '80s, late '70s? I don't know, before I was born. And the man is still churning them out, right? Still a comedy icon. Weird Al is the best. And the beer song, right? That was Weird Al, I'm pretty sure. Or was that one of like the random ass parodies on the internet that was just like ascribed to Weird Al by people that didn't know any better? I don't know. Get on that one, Twitch chat. Let me know. So x is 0 and y is 1. So we've got here again. So this is going to be a red one. And then we've got x is 1 and y is 7. Well, that was a quick jump. So we've got that one. And then we've got x is 2, y is 3. So that's this one. Then we've got 3 and 3. So that's this one. And then we've got 4 and 8. So that is 4 and 8 is this one. And then we've got 9. Wait, what? Yeah, we go all the way over to 9 and 2. And that's this one over here. Now we can see the red points. If I zoom in a bit again, because I guess I drew this a little small for these examples, didn't I? We can see that the red ones are here, 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 and here. So, yeah, I mean, a line of best fit would go where for these guys? Like to draw a straight line through these as best as I can. Like the line of best fit would be, I don't know, through here, like across there in the middle. But that doesn't accurately represent any of the points, does it? Right? Like it's being pulled up by these two and pulled back down by these 4. But even if I say that, okay, it's less up because it's 2 there and it's 4 down here, so maybe the line of best fit is across here. Still it's not good because it's below 2 of the points and above 4 of the points. It's not a great representation of either, right? Or say I was to say, oh, these 2 are clearly outliers. Let's get rid of them and just use these points. Even then, it's not great. But having 2 outliers in a set of 6 data points, right? If you've got a set of 6 data points and 2 of those 6 are outliers, you got a pretty bad set of data points there, buddy. Like, it's not even enough. You don't even have enough data to really conclusively tell if those points are outliers or not. So for 2C, we'll say no trend. Because as far as we can tell for 2C, there's not really any trend amongst those numbers. Okay? So that was a little bit of an intro there to scatter plots for you. So Esther, I hope that was useful. I also wanted to go on the same course, past the jogging girls, past the cake artists, or the chefs. Yeah, well, this is the topic I want, comparing linear and nonlinear relationships, right? No, direct and partial variation is what I wanted next. Yes. Direct and partial variation, that is page 139. Okay, so let me scroll down a little bit more. $139. Here we go. Okay. All right. So now I'm not drawing stuff out with these questions, so I'll be able to do it a little bit more like you would see normally. All right, I'm going to stick on this view though, because we need to see the page over there on the side. Have a sip of my coffee. I do have coffee here, as normal. Yes, yes, I have. I have a beer and a coffee. It's a good lunch, right? Once upon a time in my early streams, I used to show my lunch every day. Maybe I'll go back to doing that. Although I've been skipping lunch most days and just having a bigger breakfast, which is kind of why I haven't been showing it on here. Maybe I'll make some pea soup the weekend. You know, maybe I'll do that. Maybe I'll do that for tomorrow. Put a bag of peas on the soak. I actually got some salt pork. There's some salt pork that I ordered from Coleman's. Still got that. Ain't used it yet. Haven't made pea soup since that one I showed you guys on stream. So this is Math 3102A Unit 3 still. And this is page 139. This is going to be question 1. So copy and complete the table of values. What in the heck does that mean? Well, all that means is we're just going to basically take that formula. Now, it's a very, very simple formula that we're given here. Just the cost is equal to 11 times time, right? I mean, I assume that was cost and time. Maybe it's something else. Maybe it's chocolates and you know, turkeys. That doesn't make any sense whatsoever. But, you know, those are the kind of things I think of when someone asks, like, what's a word that begins with C? Chocolate. Word that begins with T? Turkey. We're done. We're done here. We did it. We solved it. Although chocolate turkey might be Smokey's favorite food in the world. He loves chocolate and he loves turkey. So, you know, chocolate turkey. It'd be the new taste sensation. So C equals 11T we have over here. These are going to be our T values, right? So all we've got is the T values of 0, 1, 2, and 3. So what do we do? How do we find what these are? Well, it's just, all we got to do is take this number, put it into this formula, and then see what result we get. So C equals 11T, C equals 11 times 0, C equals 0. Hey, look at that. What's the next one going to be, you think? C equals 11 times 1, C equals 11. There might be a pattern here. Let me just keep filling it in. There we go. Easy, right? What do you notice with the number patterns in each column? Well, these go up by 1, these go up by 11, right? Does the equation C equals 11T model a relationship with direct variation? How do you know? Well, to know that, we have to know the difference between direct and partial variation, right? So direct variation is a linear relationship with a y-intercept of 0. In other words, when one variable is 0, both are 0. Right? And then indirect variation, or partial, sorry, not indirect, direct variation and partial variation is a linear relationship where the y-intercept is non-zero. That's it. Right? It seems easy because it is. Right? I've had people do this course and be like, wait, is there nothing else to that? Why are they asking me so many times about direct and partial variation if that's really all there is to it? And guess what? That is all there is to it. Easy. Right? Take the easy stuff now while you can. I joke. All the math is easy. There's nothing difficult about it at all. So for B, I'm just not even gonna write down B because B is, we see this is going up by 1, this is going up by 11. For C, is it direct and partial variation? Well, it's direct because when T equals 0, C equals 0. Right? So that's all you got to know there. Right? It's a direct variation because when one of the variables is 0, both of them are 0. That's it. Easy stuff. Number 2, substitute the values 0, 1, 2, and 3 into the equation y equals 4x and solve for y. It's a bit too easy. It's a bit too easy, but let's do it. So we've got, here's how I normally write this out. One thing I don't like sometimes in these books is when they show you examples and all the examples are just like the absolute easiest versions of the question that you could ever possibly have. And then the first question they ask you yourself has like 7 or 8 different twists and turns to it. It's a pet peeve of mine. I feel that you should always have an example that's as complicated or more complicated even than the most complicated question you're asking the students to do. But, there's different schools of thought in the pedagogy there. Like, some university math profs might want intentionally to try to force students to, try out twists and turns on their own, right? But anyway, personally, I don't think it's super great. But hey, who am I to criticize, right? Anyway, we've got 0, 1, 2, and 3 for our x values, and now our formula is just y equals 4x. So y is equal to 4 times this number. So that's 0, that's 4, that's 8, and that's 12. Right? Direct variation? Yes. Direct because when x equals 0, y equals 0. That's all. That's all you got to do there. Now say for number 4. Let's look at number 4 for a second. Number 4 has substitute t equals da, 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 into the equation da, 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 and solve for b. So let's go across here. T and d. So t is going to be 0, 1, 2, and 3. Our formula is d equals 50t plus 5. Right? So for the first one, d equals 50 times 0 plus 5. So d equals 5. The next one, d equals 50 times 1 plus 5. D equals 55. I think you see where I'm going with this. 55, 105, 155. Right? I'm not going to go through and fill out all the rest of those. So, direct variation, explain how you know. This one is partial variation. because when t equals 0, d does not equal 0. And this is the sort of the formal way of writing it that I would be hoping for to see, right? You don't necessarily need to say when t equals 0, d equals 5. You can honestly just say when t is 0, d is not 0. And that means it's partial variation. That's it. That's all there is to it. And of course now we know that this equation over here is of what form? It's of the form y equals mx plus b, where b is the y-intercept, right? That's what these guys are of the form of. Y equals mx plus b, where b is the y-intercept. And we see here there was no y-intercept because there was no plus b. Up here there was no y-intercept, but here there was. Right? So right straight from the formula, we know then that we don't need to, we didn't even really need to graph it, although it told us to, substitute rather. 4a did tell us to come up with this, right? But we can see for part B that it's going to be partial variation right from the start because there is a non-zero y-intercept. So that's how we're going to do question 5. Question 5 is super easy. Which equations represent a relationship with direct variation? So 5a, direct. We know it's direct because there's no y-intercept, right? There's nothing added or subtracted from it. B, direct. C, direct. Right? I'm going through these pretty quick. But that's where you do have the solutions for these, right? So me just doing the solutions, giving you the solutions is not exactly changing a whole lot. Oh, for D, D is partial. Right. Why is D partial? Even though it only has one number there. That looks like it should be direct, right? But that number is just y equals 2. Right? If I just did out the line y equals 2, when x is 0, what's y going to be? Well, it's 2. It tells us that right there. Y equals 2. All the points are y equals 2. When x is 17,000, what's y going to be? 2. Right? But the important part is that when x is 0, y is still 2, which means it has a non-zero y-intercept, which means it's partial variation. So occasionally you're going to get some tricksy ones. They're going to try to trip you up. E is partial. It's partial because of that 70 that's added there, right? F is partial. G is direct. There's nothing, there's just the variable multiplied by another number, nothing added or subtracted. And then H is direct, excuse me, as well. Okay? So that Esther, should be a good start to those questions for you. Now, let me see. Let me flick back over to my intro page. There we go. We got me and the old Big Red getting some firewood for the cabin. There's a little hill. There's a little hill in the front here under where it says topics for today include. So it's not we're not getting the best perspective on my woods operation out here. But it's still a fairly good shot, work in progress sort of thing, right? Wearing my goggles and my gloves like a good former health and safety instructor that I am. Like over here, look, see, wearing my goggles here too. This is a better action shot. That's a good maul, actually. That's a splitting maul. That's like a 10-pound. It looks small. It looks like it's not much of an axe at all in this picture, right? Just because of the angle and because of all this stuff. But that is a serious axe. That thing is like it's is it 8 or 10 pounds? I can't remember now. It's a fiberglass handle, but a solid metal head on it. And let me tell you, when you're swinging around a 10-pound axe, like 10 pounds doesn't sound like a whole lot, right? You're like, I've held 10 pounds of potatoes before. That's not a whole lot of weight. But when you're swinging it around to split wood with it, let me tell you, it gets tiring after a little while. But it's satisfying too. Like when the axe comes down and cleaves like a frozen chunk of wood, and it's just like boom, it splits it right in the middle. Oh, it's good. It's good stuff. Yeah. Anyway, I can't tell if he's a redneck or a nerd or both. Anyway, we're gonna go on down now to I'm gonna do up an answer key, a bit of an answer key for this activity here, right? So yeah, tuck in, I guess, is what I'm telling you. I'm just going to kind of go down through it and ramble a bit while I'm doing it. Um, yeah, Fridays are usually my stream with the least buy-in because people are, you know, are taking a weekend early. And hey, my students have been working pretty hard. We had 17 courses completed this past month. 17, and that's not just tests. That's fully completed courses. Like some of my courses have 3 and 4 tests. Like the English and the science and stuff tend to have 1 test, but the math courses can have up to 4 tests per course, which is bonkers. But yeah, we got I don't know, doing pretty well. I think people are working pretty hard. So, I can understand taking a bit of a breather on a Friday. Either way, I'm still out here plugging away. I'm going to plug away for another few minutes. Yesterday was crazy busy because I had to get all the paperwork done for the end of the month, but that does mean that I have a lot less paperwork to cover this afternoon. And I do have to get this made, so let's go through and do it. Hey, yeah, let's do it up. So this is math 1101C, worksheet 5 key. So I'm just going to sort of talk through these questions as I'm going and doing them. Right? So question 1 here, and I've got my paper turned because I wanted oriented portrait, not landscape, for when I scan this. The two numbers have a sum of 10. The first number plus 3 times the second number is 24. Determine the numbers. Now, a lot of this math is going to be easier than some of the stuff that we've been looking at in these courses about systems of equations. It's just the difficulty of these kind of comes from the word problem part more so than from the actual, like, I don't know, number crunching. So question 1, two numbers have a sum of 10. So x plus y equals 10, right? The first number, x plus 3 times the second number, is 24, right? So I'm going to go ahead and subtract because it's already ready to be done in elimination methods. We're going to subtract, and we're going to have negative 2y equals negative 14, or y equals 7. Then we're going to have x plus 7 equals 10. Unsurprisingly, x is 3. Right? That's just all the amount of time it's going to take to go through these guys. These are going to be quick. Boom, boom, boom. Coin box of vending machine, 620 in dimes and quarters. 32 coins in total. All right, so the number of dimes plus the number of quarters is equal to 32. And now the tricky part with this one is we've got to remember to use sort of the value of the coins, right? Because the dimes plus the quarters gives us $6.20. So of course there's 10 cents per dime, 25%, 25 cents per quarter is going to give us $6.20. Now I could go ahead and do this with whole numbers instead of decimals. So I could do 10, 25, and 620 over here. Not that big a deal. Either way will work. So D is going to equal 32 minus Q. So I'm going to go ahead and plug that stuff in. So I'm going to have 0.1 times 32 minus Q plus 25 Qs equals 6.20. 3.2 minus 0.1 Q plus 0.25 Q equals 6.20. 0.15 Q is going to equal 3, right? Because I got 6.2 minus the 3.2. So then we're going to have 3 divided by 0.15, which I probably should be able to do in my head, but I can't. 20. Yeah, I should have been able to do that one in my head. Q is equal to 3 over 0.15. Q is equal to 20. Then if I go back over here, D is equal to 32 minus 20. D is equal to 12. Right? Good stuff. Question 3. 70 pucks for a total cost of 120 bucks. Pucks used for practice cost 150 each. Pucks used for games cost 225 each. How many of each type of puck did the hockey team buy? Okay, so we've got game puck and practice puck. So I'm going to call this G and P. So G plus P, game pucks and practice pucks, were 70 because we add both those guys together, right? And then we've got, so that's going to give us, I'm going to do this again through substitution, 70 minus P. So the number of game pucks is 70 minus the number of practice pucks. So then we have, let's see, this is a good question, right? With the getup I'm wearing today. I don't know why a denim is considered a Canadian tuxedo, right? It should be plaid. Practice costs $1.50 each, so $1.50 times practice plus $2.25 times game is going to equal 120. What's ever hear the joke? What's Mario's coveralls made out of? Denim, denim, denim. So I apologize. I apologize for that joke. 2.25 times 70, 157.5. Oh, P is equal to 50. Denim, denim, denim. Denim, denim, denim. Denim, 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 denim. Oh, that was question 4, wasn't it? That was question 4. You know what? Maybe me making my proper keys on stream is not the best idea. Hey, because I kind of already messed it up. I don't want to scan this in now. I don't want to scan it in with like 1, 2, 4, and 3 over here. That's a bit silly. That's gonna look weird to anybody else seeing it. I don't know. I don't know. I don't know, Twitch chat. Maybe I'll no, I'll tell you what, I'll keep on going. I'll keep on going. Cram question 3 in over here. It's fine. It's fine. Tell you what, I'll just use it myself. I'll just save this and keep it locally. I don't need to upload this. One number is added to another number. The result is 29. Double the first number is added to the second. The result is 16. Okay. So x plus y equals, one number is added to a double another number. X plus 2y is 29. 2x plus y is equal to 16. Okay, cool. So I'm going to let me bring this one down here, say, and I'll call this 2x plus 4y is equal to 58. Then I'm going to go ahead and subtract. So I'll call this negative 3y is equal to, what is that, negative 42. So then y is going to equal, what is that, 16? 42 over 3? 14. 14. Y is equal to 14. That's that easy, right? So then 2x plus 14 is equal to 16. 2x is equal to 2. X is equal to 1. Good stuff, right? Easy peasy. Let's do a few more of these. You're seeing now that these are fairly fast, aren't they? So number 5, Nicole purchased 5 boxes of chocolates and candies. The reverse. Hey, I did that one on stream only recently, didn't I? You know what? I've already messed this up. I've already messed up this this key. So let's just go ahead and do number 6 instead, because I haven't done number 6 on stream yet. 27 students in Ms. King's math class. The number of girls in the class is 3, more than twice the number of boys. Determine how many boys and girls are in the class. Okay. 27 students, so we know that the number of boys plus the number of girls is going to be 27. Number of girls in the class is 3 more than twice the number of boys. So girls is equal to 3 more than twice the boys. Okay? So we've already got it in a form that we can go straight ahead and substitute it in. So we've got boy plus 3 plus 2 boy equals 27. 3 boy is going to equal 24. So then boy is going to equal, it's got to equal 8. Right? So then if boy plus girl is 27, 8 plus the number of girls is equal to 27. Number of girls is going to equal 19. And does that make sense from what we were told from the start? 3 more than twice the number of boys? Yep, makes sense. And if we add them together, we do get back to 27. Easy stuff, right? Number 7. The sum of a number and twice a second number is 16. So a number plus twice another number is going to give us 16. The first number is 4 greater than the second number. So x is 4 greater than the second number. Well, easy stuff. So I'm just going to take this now and substitute it in. So we have 4 plus y plus 2y equals 16. Right, that is what we're told. Sum of a number and twice a second number is 16. First number is 4. Okay, sure. 3y is going to equal 12. Y is going to equal to 4. I don't know why I just had like a brain fart there. I'm doing this right. Just for a second, for a hot second there, I was like, what in the world am I doing? But yeah, this is obviously right. X plus 2 times 4 is 16. X is equal to 8. Right? Hey, good stuff. Easy peasy. Let's cram number 8 here on this page as well, shall we? Number 8 down here. So the larger of two numbers is equal to 3 times the smaller number. So x is equal to 3 times y. Twice the larger number is added to 3 times the smaller number. The sum is 27. Well, we're already told that x equals 3y. Here's another one like I showed before where we can sort of substitute more easily, right? Because we know that x equals 3y, so I could put 3y in here, but I also know that 3y is equal to x, so I could put an x over here. I can just call this 2x plus x equals 27, or that again means x equals 9. So 9 is equal to 3y, 3 is equal to y. Right? Easy stuff. So, seeing I started this, I'm going to finish. I'm going to finish, and I'm going to, yeah, we've only got 4 more. Worksheet 5 key, so now number 9. 3 times Nancy's age is 6 more than twice Roger's age. Yikes. Okay. So 3 Nancy is 6 more than twice Roger. Okay. And then the sum of their ages is 32. So, Nancy plus Roger equals 32. So now we just have to rearrange these into some form where we can use one of the methods that we've done. So I'm going to get, let's get n by itself. Let's just do n equals 32 minus r. And I'm going to take this one down and I'm going to substitute into it. 3 times 32 minus r is equal to 6 plus 2r. Looks like I'm making more work for myself for a second here, but it'll work out easily enough. So this is 96 minus 3r is equal to 6 plus 2r, like so, right? So then we have 90 is equal to 5 times r. So then 18 is going to equal r, right? So then if n plus 18 is going to be 32, we know that n is 14, right? Does that work? 3 times Nancy's age, well, 3 times 14 is going to be 42. twice Roger's age is going to be 36, and 36 is indeed 6 smaller than 42. So we got there. Always good to check your work. Number 10, twice the length of a rectangle is equal to 5 times its width. Okay, sure. So twice the length. Oh, I did this one. I did this one on stream already. Okay? Never mind. I'll skip that. Let's do 11 instead. Did that one on stream. Rachel sold 7 adult tickets and 3 student tickets and got 10.25. Okay, so 7 adult tickets plus 3 student tickets gave her 10.25. Sister sold 3 adult plus 7 student and got 7.25. Okay, so here now, these ones are maybe a little bit of a pain because we don't have a straightforward way to do either elimination or substitution here necessarily. But I'm going to go ahead and I'm going to multiply this whole one by 3. This is not the correct notation. I'm just going to write it out like that. So that's going to be 21a plus 9s equals 3075, like so. I'm going to do this one times 7. I seem to recall having done this one as well, but who knows? Equals 725 times 7 is 49. 49 plus $1.75, 50.75. Right? Just want to make sure that that's correct. Doing stuff in your head is nice, but you know, you got a calculator with you on a test. There's no excuse. No excuse for getting arithmetic wrong. You might as well go figure it out, right? You can check it. There are plenty of ways to check it. So now I'm going to go ahead and subtract Reno cappuccino. Negative 40s is going to equal negative 20. Yeah, I definitely did this already, didn't I? S is equal to 0.5. And we're just going to go back and substitute in. 3a plus 7 times a half is equal to 725. 3a plus 350 is equal to 725. 3a is going to equal 375, right? Yep, 375 divided by 3 is going to give us $1.25. A is equal to $1.25. Easy, right? That's all there is to that one. And now we're almost done, aren't we? We're on the last one. It didn't take long. Didn't take long to tear through this page, did it? Okay, so Lisa purchased 5 pencils and 3 pens for a total of $8.52. Chad purchased 2 pencils and 4 pens for a total of $5.76. Determine the cost of each item. Okay, so pencils and pens, boy. That's annoying. It's annoying that they're both PE. PEN and PEN even. Okay. So I'll use C and S because it's the first letter of the two that's different. So 5 pencil plus 3 pens gave them $8.52. Now it's much more Chadley to purchase 2 pencils and 4 pens for a total of $5.76. Okay, so I'm going to take these now and I'm going to times this by 2, and I'm going to get 10 pencils plus 6 pens is equal to 16 and $1.04, 17.04. Then down here, this is going to be a times 5, so it's going to be 10C plus 20S is equal to 5 times 5 is 25. 75 times 5 will be $1.25. And then one more is $1.30, so that should be $26.30. Okay. Wait. No. 28.80. 28.80. What am I doing? Right? Because I was thinking 25. I was thinking 25. Chat. I was thinking 25. See? Hey, don't trust your brain. Don't trust your brain. Trust your calculator. Right, but I'm going to go ahead now and subtract these guys. So we're going to get a negative 14. S is going to be negative 1176. Divide that by 14, and we're going to get S is equal to 0.84 or 84 cents, right? So then if we've got 2C plus 4 times 0.84, it's going to equal 576. 2C is equal to 5.76 plus 3.36, right? 2C is going to equal 912. Am I doing something wrong here? Yes, I am. All right. Well, trying to go too fast. Trying to go too fast. 5.76 subtract 3.36. 2.4. C is equal to $1.20. Now that makes more sense. There we go. See? When you try to rush, you make mistakes. Okay. Well, that was everything that I wanted to get to today, right? Thanks for, oh, whoa. There we go. Thanks for sticking it out with me here today, despite my my getup. Let me put my chapeau back on. There we go. Right? Good stuff. My invisible hat. Okay. So it's yeah, it's another week down. 24 streams, 5 weeks. Wow. Wow. I can't believe I've been doing distance teaching now for 5 weeks of active teaching. 1 week we were off because of Easter break. So we've really been doing distance for 6 weeks. And there was a week before that I was prepping for this all. So it's kind of 7 weeks. But either way, 5 weeks of distance teaching classes. Hey, we got a few more to go. We got maybe what? Maybe 8 weeks more for this program. So hey, we might be up to day like 64 by the time we're done, or 63, I guess, because there's at least one other break there. Maybe I'll have to go to day 64. Maybe on day 64 I'll play N64. Yeah, that sounds good. Maybe Mario 64, GoldenEye, Perfect Dark, original Smash Bros. Yeah, Smash Bros 64. Although Melee is superior. Everyone knows that. Everyone knows that. Melee is real Smash. Ultimate's pretty good. Like Ultimate's fine. I like Ultimate. But Melee is my jam. Anyway, I will play N64 though. That'd be fun. That'd be if I head out to for May 2-4, maybe I can get my N64. I've got an actual factual proper, physical N64 out of my parents' place. Ooh, that'd be fun. Although I don't have a capture card for it. I just had to point my webcam at a TV. That's a bit janky. Anyway, thanks for sticking it out here on this Friday. Right? I hope anybody, um, anyone who's working on these topics right now, maybe found this the stream useful. Again, let me know via email if you got any questions for me to do, and I'll definitely get to those on the next stream. All right? But this was a great month of work for everybody at my campus. So thanks very much. You're take a well-deserved weekend break, and I'll see you again back at it on Monday. All right? Stay safe and have a great time.